Hi students, today in this class I'm going to discussing some applications on work done. In the last class I discussed some numericals based on the work and after this one now I finished the work done by the constant force and variable force. So based on that I completed the numericals on the work done by constant force and variable force. Now in this video I am discussing some of the applications on work done. See the first application is here. Work done in pulling the bob of mass m of a simple pendulum. So now here I am taking the simple pendulum of length is L is given through an angle theta. It is making an angle. This angle is vertical. It is vertical, so by means of a horizontal force also is given. Okay, right. So this is the given applications. Maybe this type of applications, how the work done will be proved in this case. Okay, see, first I will draw the simple pendulum diagram. I will take first, see, this is the one horizontal support like ceiling. I am taking a simple pendulum. This is the bob. Here we can see in the application, bob of mass is given here, m. So I am taking this is the bob mass in this case, m. So similarly, if you observe of length, the length of the string is given here, capital L. So means from here, the total length of the string is here given. This one is given here. Length is L. This is the length is given. So right, what is happening after that? Work done in pulling the bob in this case. Work done pulling. So by means in this case, horizontal force in this case. Means, so we are applying forces like this. If you pull this object this direction, horizontal direction. So what will be happen, this bob it will move upward in this case. See here everyone. See, once if you apply the horizontal force, so the bob will reach this particular height is like that. So this is the horizontal force only when you applied. So if you observe here, this is simple pendulum, this yellow one is making with vertical is theta. So that point only is given in this application. An angle theta to the vertical. This one. Okay, right. Now we can see here. Right. This is the theta. Now, suppose actually this bob, if you observe, this is the position actually. Now we can see what is the height of this bob is reached means here something I will take h. Okay, so this is the actual position of the bob in this case, but it is moved like this. It is moved to upward in this case. So nothing but how much of height is moved here means I took some particular height is that is h only. Now I will take one horizontal line to the final position of the bob. So this is the height is h here. This is the h because of this point and this points both are equal heights in this case. Now I am taking, so This is the point. I will keep some point names. This bob point is the B, and this is the C, and this point I'm considering in this case A. On the top, the point of suspension I'm taking in this case O. If you observe this diagram, OAC is like a triangle in this case. OAC is a triangular shape, and the total length of the string is in this case is a capital L. Okay, so means this length also will be here L only. So we are taking in this case a string means what happened in the string there is a tensional force is acting. The tensional force is always acting away from the object. If I will take this is the object here, the bob is the object. Away from the object means in this case the tension is acting here this direction along the string but upward. This is the tension. Okay. Similarly, at the bob, the weight is acting downward like this. This is the m into g weight. So here, how many number of forces are acting means here. See, this is the first one. Weight is the one of the force. Horizontal force is the second one, and tension is the third one. Total three forces acting on this bob in this case. Okay, right. So work done formula, we know work is equal to force into displacement. So first I will take work done by the gravity, nothing but W is equal to mg. Now I will take work done is equal to horizontal force, that is the second work done, and third one I will take work done on the tension T. Total three works it will be happen here. So then finally I will take the resultant work done, W is equal to W1 plus W2 plus W3. Then finally I will get how much of work is happening on this system in this case. Okay, right now. So before going to this one, see total length is L, and yeah, AB distance is the H in this case, OB distance is the L, but I want the OA distance. How to find? How to find the see here OB distance is given capital L, and AB distance I consider in this case H. Then OA is equal to total distance, nothing but OB minus AB. OB is equal to total length is L here, and AB distance is given here H. So OA is nothing but in this case something X. OA is equal here L minus H. This is L minus H. Please consider this one. Okay, right. Now I will take first one in this case, work done by the gravitational force. First force I'm considering in this case. Work done by first one is work done by gravitational force. Right. This one. Right. So if I will take like a diagram, once I will draw here. This is the bob. So bob gravity is acting, weight is acting downward. This is the weight of the bob is downward. W is equal to here m into g. Now initially the bob is maybe here like this. So how much of distance it will go upside means, so I took the horizontal line. So from here to here the height is h. So h distance the bob is travel. Now we can see this is the horizontal line. If I take this is the initially one, so the bob is going to upward in this case. So means the height is upward, the body is going up. This is the h. Now we can observe in this case the angle between h and mg here 180 degrees. This is the angle between these two is here 180 degrees. I'm considering the formula. W is equal to force into displacement, or Fs cos theta. Here force is nothing but gravitational force. This F is nothing but here gravitational force. Gravitational force formula is m into g, and S is nothing but displacement. Displacement is nothing but here is the height is h. So h cos theta is 180 degrees. I showed in the diagram. So that is equal to m into g into h. Cos 180 value is minus 1. That is equal to work done is here minus mgh. This is the final work done. Right. So h I want to find. Suppose they will ask sometimes h value also. In the previous diagram, once we can observe there, this is the point is O. This is the point is I to P A, and this is the point is C. Okay. So this is the L minus H. If you see the previous diagram, this is the L minus H, and the length of the string is L, and this is the angle is theta. I want this one here. I want to find out the what in this case H I want to find out, right? So how to find H means in this case, this is I don't know something X I'm considering this is. So I want the H means first I will take in this case cos theta formula. Cos theta formula is here adjacent side divided by hypotenuse. Cos theta is equal to adjacent side is here L minus H. So L minus H divided by hypotenuse is nothing but here L. So write L. Now take the cross multiplication this L that side. Then cos theta into L is equal to L minus H. Okay. Then if you take H is equal to L minus L cos theta. H is equal to L if you take common 1 minus cos theta. So finally I got the H value. This H value we can substitute in this formula. Then W is equal to minus M into G. So in the place of H I am taking 1 minus cos theta. So L into L is there into L. So this is the final work done. How much of is happening in terms of theta without H lengthwise. Right. This is the one case. Now come to the here second one. Second work done is a horizontal force, I think. Work done by horizontal force. Again, I'm considering the diagram there. So this is the horizontal force for that bob is F. But initially this is the position of the bob. It went like this. Then how much of this displacement is travel means see this side also. This is nothing but. So I need to find out this distance how much because the horizontal force, right? I want the displacement of how much of this body is moving from the initial position to final position on a horizontal wise. Already this point we called as in this case C. This point we called as here B. This point we called as is A, and this is the simple position will be like this, right? Theta. This is the x we need to find out this. This is the L minus H and this is the L. Now I will take the sine theta here. If I will take sine theta, formula is what? Opposite direction divided by hypotenuse. So sine theta, opposite direction is nothing but here x divided by hypotenuse is nothing but here L. Then finally x is equal to L into sine theta. So displacement I got it in this case x here is equal to L sine theta in this case. Okay, right. So what is the formula for this one? Again work done is equal to same formula only, force into displacement into cos theta. Okay, that is equal to force is nothing but horizontal force only, nothing but F. Displacement is nothing but in this case x, right? How much of displacement is travel in this case? X distance is travel, nothing but L sine theta. Okay, but here cos theta, theta is the angle between force and displacement. Here both are the same direction only. This is the displacement and this is the force. The angle between these two is equal to here 0 degrees. Then cos 0 value is 1 in this case. That is equal to FL sine theta. W is equal to FL sine theta. This is the final answer. Work done by the horizontal force. Right. So, and the last one is in this case work done by third one I'm taking. Work done by tension force. T. Okay. Right. Tension force is T. So diagram see here. This is the bob. Tension force is the this side. Okay. And displacement also we want. If we take this is the initial position of the bob, it is going to like this. So at this point, this is the direction of the displacement. Tangent line. Actually, the path is forming like this, but this is the tangent line is nothing but displacement direction is this side in this case. So now you can observe this one. The angle between these two is here 90 degrees. So I'm taking the formula. Work done is equal to Fs cos theta. Here force is nothing but tension. T, displacement is nothing but here something I'm taking L or X I'm considering, and cos theta. Cos theta is nothing but cos 90 degree. Cos 90 degrees is 0. Then finally the work done by the tension is 0 because the displacement and tension both are in the 90 degrees. When theta is equal to 90 degrees, the work done will be 0. So total three forces are there. One is the gravitational force, second one is the horizontal force, and third one is the tension force. So according to these three forces, I found out the work done in this case. Okay. So if you want to final work done, you can take total work done in this case. Total work done W is equal to W1 plus W2 plus W, the total of three forces. First one I found here minus mgl into 1 minus cos theta plus second one is fl sin theta, third one will be 0. So that is equal to fl sin theta minus mgl 1 minus cos theta. This is the final work done on this system. Nothing but a simple pendulum. That's it. Thank you so much.